Hello everyone, greetings from Singapore. My name is Prashant Ketan. I'm a Senior Product Executive with Olympus Singapore. In today's video, we'll be looking at the performance verifications required to perform a TFM FMC inspection as per the new ASME Section 5. So in the past few years, we have seen the requirement or the interest for this TFM FMC inspections have been going up, so as the need for governing codes to be established. The latest versions of ASME and ISO have incorporated the guidelines and the requirements to perform these inspections. Today, we will look into the requirements for ASME Section 5. So, in order to demonstrate that, I have already made a setup with 4 groups. So, in our previous videos, we have already seen how to configure multi-group TFM. So, we'll be using a 5L32 A32 probe and with a 4 group setup in which we have 2T and 4T, which are the direct wave sets, also the 3T and 5T, which are the self-random or indirect wave sets. So we also have a calibration block designed as per ASME requirements. So it is 15 thick, and we have sidle holes drilled at the same face. We also have a 1-inch long cap notch with depth of 10% of the thickness. We also have a through wall slot of 6 length. So these are the 3 reflectors which are basically required in order to perform your performance verifications as per ASME. So before we look into individual requirements, so we will be collecting the data for these 3 reflectors. So we will be using the multiple group in order to visualize both the top and end scan. So let's position our probe and start the acquisition. So we'll be recording over the sidle holes first, then moving towards our cap notch, and also our through wall slot. Okay. So now that we have collected the data for all the 3 reflectors, we'll go through one by one the requirements, the verification requirements. First up is a system resolution verification, which is the ability to image the spatial distance between the sidle holes. So our block, we have on the face of one of the face, we have 2 sidle holes at 1/4 and 3/4 of the thickness. So as you can see in our 4T mode, which is a full skip, so we are able to distinguish very clearly both the holes and also the gap in between them. So the next requirement is a path verification, which has to be done for both direct and the self-tandem wavesets. So that there are 2 main requirements. The first thing is that each and every reflector has to be detected by minimum of 2 imaging path or wavesets. So as you can see here, so if you look at our first reflectors, which are our sidle holes, you can see from our top view, we have a very good detection in almost all the 3. If we are looking at the cap notch, the second reflector, we can see in 4T and also in our 5T mode. Okay, this is the imaging in our 4T, and also this is our imaging in our 5T. So when we are looking at our through wall slot, we can see the bottom half of the defect in our 3T and also the top half of our defect in our 5T. So this brings up to the next requirement in the path verification, that is to ensure that we have complete coverage over the reflectors we're looking at. So going back to our sidle holes, so if you look at the 2T mode, we can see here we are only able to image the 3/4 thickness hole because of the coverage itself. But the same is compensated by the 4T mode, which is able to detect both of them. So we need to ensure that if we lack certain coverage in one of the group, we have adequately compensated by using a different group or a different scan. Similarly, if you look at our cap notch, so we have entirely imaged the defect using our 4T and 5T. So when it comes to the through wall slot, When we look at our direct modes, so we only see the tips of the defects. So this is the image or the bottom tip from our 2T. So this is from our 4T, where we can see only the tips of the defects. So we have this self-random modes, which are very sensitive to vertical type of defects. And we can see a very good reflection or very good coverage and imaging of the entirety of the through-wall slot. So here we can see the bottom half of the defect in our 3T mode. And in our 5T mode, we are able to see the top half of the defect. And the final verification, what we have is a sizing verification. This is done using the notch. So we'll be using our top view for the length measurement and the end view for our height measurement. So bringing out our cursors. So we set the reference at one end of the indication and the measurement on the other end. Similarly for our height measurement. So we set the reference at 0 and we move our measurement cursor to the end of the defect. Okay. So from this, we are able to measure both the length and the height of the defect. So as you can see, the measured length is about 28 mm and the measured depth is 1.57. So as per the ASME requirements, the measured length and the height shall not be less than the actual dimensions, which is in this case. And also it shall not exceed by 50% or 4 mm of the known height. And also shall not exceed 50% of the known length. So we have here is a 25 mm notch with a 1.5 mm depth. So this also is able to comply with the requirements. So with this multi-group setup, we are able to comply with all the 3 performance verification checks as per the ASME Section 5. I hope this video is insightful. If you have any queries, please contact your local representatives. Thank you and have a nice day.